HR invested 15,000 in order to train 30 of their 200 customer service representatives in order to improve the customer satisfaction score, CSAT, as well as the average handling time of calls by these customer service reps, right? And so, in order to justify training the remainder of the 200 of the customer service reps, HR tasked me, the in-house data analyst, in order to ensure that there is indeed a statistically significant improvement in these metrics of the customer service reps who were actually trained. And so, how would I, the data analyst, go about this? I would use a paired samples t-test because it is the tool to go to in order to compare the before and the after um, due to a particular effect, which in this case is the training. We would look at the CSAT before and we would look at the CSAT after, and this statistical tool will enable us to test indeed if there was a statistically significant improvement between these two, right? And these are the two hypotheses I would be doing for each of these metrics, being the first hypothesis or the null hypothesis that there was no satisfaction, there was no improvement, training had no improvement, caused no improvement to customer satisfaction, as well as the alternative hypothesis being that training significantly improved customer satisfaction. So this is the data I'll be using, and in this case, I'm using Python in order to conduct the t-test where I imported the SciPy and the stats module, and conducting the t-test with these modules, comparing CSAT after to CSAT before. Similarly for AHT. The rest of the code is just in order to display the results of this test. And so, excuse me for that, it's flu season. These are the outcomes. Looking at the mean CSAT before the baseline, it was 70, and now it is 81% after the training. And then with the statistical test we conducted, this was its t statistic and its p-value. And you notice that this p-value, e to the negative 18, is a very small number, which is way below 5%. And so with this, we can conclude that there's a highly significant improvement due to the training that HR conducted. This is the case for both AHT and CSAT, right? And so it can also be the case that maybe HR didn't just want to test before and after. They might have wanted to test before and then 1 week after training and then maybe 6 months after training. And in that case, I wouldn't use the paired t-test, the paired samples t-test. Instead, I would use the repeated measures ANOVA test. Yes, that would be the relevant test for that case. And so here's a visualization I made in order to just demonstrate the improvement in CSAT score from before to after training. Similarly, so the decrease in the handling time for calls. All right, so beyond the visualizations and beyond Python, this test can also be conducted in Excel, which I know is pretty much the premier option for institutions with regards to all the numerical and quantification. And I'll try to speed through how I would conduct the same test using the same data on Excel, right? So I need to do a special paste of this data, paste special. Let's roll the dice. I believe it's text. Nice. So it's text. There's a misalignment here. Rep ID should go over that side. Control X, da da da, Control V. Nice. I can delete this. And then let's turn this data into a table. Control T. Yes, please. Nice. And in order to do data analysis in Excel, we're going to need the data tab, data analysis, and we're going to conduct the paired two samples for means, right? Let's go. And so, there we go. Da, da, da. Come on. Okay, I've already done a selection. Let's undo that for a second. There we go. Right, trying to speed through this so that I save your time. I do not want to take up too much of your time. And we'll include the label. Okay, let's take that. Last but not least, we'll take this as well. CSAT before, CSAT after. Okay, and then a new worksheet will be fine. Let's hit. Oh, I did not add labels. That was the case. Lord. Oh yeah, and we can see similar results. Um, the main similarity we'll see here is that the t statistic is still the p value and the t statistics are relatively the same to what we saw with Python this side. And since they're relatively the same, we can still come to the same conclusions we had arrived to in this particular case. And last but not least, you might be wondering, okay, where did Gabo get this data? In this case, I actually synthesized the data. You can download, I'll leave a link to this notebook so that you can download it yourself and you can conduct tests and use the code however you want to. And so I synthesized the data in this section of the code. Generally, people would prefer maybe if I had got the data from Kaggle, like here, looking for staff training data. But in that case, this video would be long. I'd have to go through EDA for that particular data, check for errors, check for null values, and then ensure that the data is normally distributed if I wanted to conduct this t-test. And if it's not, I'd have to do non-parametric tests. And then the technicalities build together. And I'll explore these in other videos, but I wanted to keep this video short and concise. Thank you for your time, and please comment any improvements on how I can improve this video and its delivery. Cheers. Bye-bye.